Okay, question number 5. Is the segment y equal negative 1/2 x plus 3? Is that the perpendicular bisector of the segment with endpoints 2, 9 and negative 4, negative 3? Why or why not? Okay, so let's see what it looks like on the graph. This is 2, 9 and negative 4, negative 3. So let's look at the slope of this thing. From here to here, this is up. So from negative 3 to 9, we're going up 3, then up 9 more. So this is up 12. And then to the right, from negative 4, from x equal negative 4 to x equal 2. So that's right 4, then right 2 more, that's right 6. Up 12 and right 6. So that's slope of positive 2. So this could be the perpendicular bisector because it has the correct slope. So the other thing we need is, are we passing through the midpoint? The perpendicular bisector has to pass through the midpoint of this negative 1/2 x plus 3. So we're talking about this. So there's your negative 1/2 x plus 3. And does it pass through the midpoint of this line with the endpoints at 2, 9 and negative 4, negative 3? So we have to find the midpoint of the blue line. So the midpoint of the blue line, take the x values, 2 and negative 4, and add them and get negative 2. Negative 2 divided by 2, negative 1. X equal negative 1. And the y value, so y of negative 3 plus y of 9 equals y of 6. Then 6 divided by 2, 3. So the midpoint of this blue line is here at negative 1, 3. So for this other line, negative 1/2 x plus 3, for this to be the perpendicular bisector of the blue line, it would need to pass through this coordinate negative 1, 3, but it does not. So we would say no, the perpendicular bisector of L is, so we could figure out the equation for the perpendicular bisector. It needs slope of negative 1/2, and then it needs to go through this coordinate negative 1, 3. So left 1 and up 3. So here it is in point slope form. This is the true bisector, and so then when we simplify the true bisector, we have negative 1/2 times x, and then negative 1/2 times 1 is negative 1/2, and then plus 3. So when we simplify this part, negative 1/2 plus 3, that's 5 over 2, or 2.5. This is negative 1/2 x plus 2.5. So it is not, and that is the perpendicular bisector. So then that means this one, where it's negative 1/2 x plus 3, that is not the perpendicular bisector because it doesn't pass through the midpoint. It's a little bit above. That was a really long explanation. Thanks for really digging in and diving in and getting it thoroughly correct. Okay, item 6. Find the equation of the perpendicular bisector of the segment with endpoints 2, 5 and 8, 3, and put this perpendicular bisector equation in slope-intercept form, mx plus b. Okay, so let's use these endpoints and find the slope and the midpoint. Okay, so the slope of this original, we're going from, here's 2, 5, and then 8, 3. So down from 5 to 3, that's down 2. And then going to the right, from 2 to 8, that's right 6. So down 2, right 6, or down 1, right 3. Slope of negative 1/3. Then what is the midpoint of this little line segment? Well, we've got 2 plus 8 is 10. 10 divided by 2 is 5. That's the x-coordinate of the midpoint. Then the y-coordinate, 5 plus 3 is 8 divided by 2 is 4, the y-coordinate. So we're at 5 comma 4, the midpoint of this little line segment. Now to find the perpendicular bisector, we need to change the slope. So we need to go from negative to positive and go from 1/3 to 3. Oh, sorry. Then we have to go through the coordinate 5 comma 4. That's right 5 and up 4. X minus 5, then plus 4. Now simplify by distributing the 3. And finish with y equals 3x minus 11 as the slope-intercept form of the perpendicular bisector. Let's just keep going. All right, here we go. Number 7. Okay, so in my copy of the question, there's some stuff that's not written that we will fix and put in your copy of the question, but we need this information to do the problem. So the perpendicular bisector of AB with A at 5 comma 5 and B at negative 3 comma 1. So its perpendicular bisector passes through the point M, and so M is the midpoint of AB, and we're calling this perpendicular bisector line C. Then the perpendicular bisector of AM, here's point M, we'll find it in a minute. The perpendicular bisector of AM passes through the point N. This is the midpoint of AM. Here's A, here's M. So that means N, the midpoint about here, that's N. Point N, and that's called line D. So it's going to look something like that. And this is getting kind of crowded, but this is point N. Okay, so in order to figure out what is the slope of these perpendicular lines, we have to find the slope of AB. So from B to A, going to the right, we move up 4 and right 8 units. So slope of AB is 1/2. So that means the slope of the perpendicular bisector C, we'll take that 1/2, we'll change the sign to negative, and then we'll flip to the reciprocal of 1/2, which is 2. We need to know the point to pass through, so we use the midpoint equation. So we have x equal 5 for A, x equal negative 3 for B. So 5 plus negative 3 is 2, and then 2 divided by 2 is 1. So x coordinate of 1. And then the y-coordinate, we have y equal 5 and y equal 1. So we add those and get 6. Then 6 divided by 2, 3. So the midpoint, x comma y, at 1 comma 3. So that means that the equation of line C, the perpendicular bisector of AB, is a line with a slope of negative 2, passing through the point 1 comma 3. This is right 1 and up 3. So that's the answer to this first question. Determine the equation of line C in point slope form. Then take that same line equation and write it in slope intercept form. So we'll have negative 2 times x, negative 2x. Negative 2 times negative 1 is positive 2. And then plus 3 more on the outside. So plus 3, and then we'll simplify 2 plus 3 and get 5. So y equals negative 2x plus 5. Okay, now the equation of line D. So the equation of line D, for D, we're going to have this slope of negative 2 because D is perpendicular to AB, just like C is perpendicular to AB. In fact, line C and line D are, that's right, they're parallel. They have the same slope. So this is for D. Y equals negative 2 times something. So we have to pass it through the midpoint. So to find the midpoint between A and M, because that's what we're working with now, again, we'll do the average of the X and Y values. So midpoint AM. Okay, so we have X values of X equal 1 and X equal 5. Then for the Y values, we have Y equal 3 and Y equal 5. So here we have 6 over 2 is 3. Here we have 8 over 2 is 4. So that means we need to pass this line through the coordinate 3, 4. That's right 3 and up 4. So this is x minus 3 plus 4. Okay, finally, line D in slope-intercept form. So we'll have y equals, distribute negative 2x, minus 2 times minus 3, that's plus 6, then plus 4 more on the outside. So this is negative 2x plus 10. And if we go and look at our graph of this red line, we should see that if we go back to the y-axis, you see this slope of negative 2 coming down here. You see that this will pass through that y-intercept at 0, 10. Great job, Smarty Pants. Let's extend this line so people know what's going on here. That's line D and line C, the parallel one. Uh-oh. There we go, there's line C. That's it. Lesson's done. Pat yourself on the back.